Hi, I'm the Global Brand Ambassador for Majestic. Majestic is a specialist search engine that spent the last decade scrolling the internet and having a look at the backlinks into web pages and using that as a way to map the internet. Before that, I worked again for probably 10 years at founding the SEO agency Receptional in the UK. So I've got around about 20 years in the industry. When I went on holiday this year in Croatia, Dubrovnik, a maths teacher came up to me and asked me what this meant on my t-shirt. And it dawned on me that even at conferences like this, people don't understand what this algorithm means. So at the end of this presentation, you will know. This matrix, of course, is the PageRank algorithm. And the algorithm is the one that made Larry Page and Sergey Brin two of the richest people and most powerful people in the world. This is the maths that built Google. And you can just read it. It says, the PageRank of a page in this iteration equals 1 minus a dampening factor plus, for every link into that page, add the PageRank of that page divided by the number of outbound links on that page and reduce that by the dampening factor, as long as you're not counting a page linking to itself. Easy, right? Well, okay, maybe for a few of you. But this algorithm is fundamental in understanding links, and in particular, in understanding why most links count for nothing or almost nothing on the internet. When you get to grips with this algorithm, you'll usually be light years ahead of other SEOs, but I never really see it properly explained. And I guarantee that even if you know this algorithm inside out, you'll see some unexpected results from this maths. And you'll also, I hope, never use the phrase domain authority in front of another customer, again, at least in relation to links. Now, I should say I'm not asking anyone here to know much more than simple Excel for this presentation. And I'm going to start showing you how the maths in the calculation here applies to this representation of a very small internet system of only 5 nodes. Then we're going to look at a very slightly different map which has profound consequences to our results. So the PageRank algorithm is called an iterative algorithm. We start by some estimates and then we continually refine our understanding of the ecosystem that we're measuring. So how can we see how the PageRank formula applies to this ecosystem? Firstly, we need to create a matrix. We have the nodes A to E, which I've put into columns, and we're going to call them pages for now, but nodes is correct terminology, but I'm going to use the word pages because we understand pages in the SEO world, but nodes is important, as we'll find out later. I'm also going to put in a start value, and I'm going to put in the number of links into each page as my first row. So page A has 1 link coming into it, page B has 2 links coming into it, etc., across. And we can see that from the chart in the top right hand corner. And then I'm going to have to look at the outlinks as well. So the outlinks, page A is only linking out to 1 page, which is page C, whereas page C, for example, is linking out to 3 pages, A, B, and E. Okay. Interestingly, page D actually only links out to 2 nodes. D links to B and D links to E, but of course it's linking to E 3 times. And in this version, we don't count the other 2 links because either there's a link from D to E or there isn't. So I'm going to put 2 in that particular column of D. Okay. Now, also we need to say, well, if a site can't link to itself, so we'll put a red bar through AA, BB, CC, etc., etc. Now, we're going to have a look and see in this matrix where there is a link between 2 nodes. So, for example, page A links to page C. Page B links to page C. Page C links out to page A, B, and E. So it's got 3 links coming out. We can check that by seeing the number of outlinks. D and E. So now we've filled in the whole of our matrix and we can see the green spots, and the number of green spots should add up to the number of backlinks and it should add up to the number of outlinks. They should all add up to the same number. Okay. So here's the grid. We can check those numbers. That 8 is very useful. It's a good reason for us to use backlinks as a place to start here. But the PageRank algorithm doesn't start with backlinks. It starts with an estimate, an initial estimate of PageRank. Now, most people, when they use the PageRank algorithm, start by saying that every page initially is worth 1 point. I'm not going to do that. We found that if we estimate that the PageRank starts with the number of links coming in or any other better estimate, then we're going to save ourselves a lot of computing time, and Majestic needs a lot of computing time. So better to use the link count or some other proxy for PageRank as a first estimate. So we're going to use the link counts, the number of in links, as our initial estimate of PageRank in this calculation. And we also have in the calculation a damping factor. Now, damping factor is mostly, in most of the documentations of the scene, where it has been specified is 0.15, so we're going to use that. So that's to say that we don't want all of the power of a page to be dissipated out by the links. We're going to have 0.85 of it out, so we're going to dampen it down by 0.15. So the opposite of 0.15, 1 minus D, 1 minus a dampening factor, will be 0.85. So now we can work out a multiplier for every single page. And the multiplier for every single page is the PageRank that we have, multiplied by 1 minus the dampening factor, 1 minus 0.15, divided by the number of outlinks. Now, we can simplify that, in fact, so that it's PageRank times 0.085 divided by the number of outlinks. Now, one thing I should say here that I'm not going to cover in this presentation is what if the number of outlinks is 0? What if a page doesn't link out? Because in theory, that would mean that you're then dividing by 0, which causes all sorts of problems to this algorithm. And that does get a little bit complicated for us to explain. So I'm going to have an ecosystem where people are linking out on all of the pages. But we can then fill in this table a little bit more. So in this table, we've got for example, page A has initially a PageRank of 1, which we're going to multiply by 0.85 and divide by the single outbound link. So the multiplier is 0.85 in column A. Whereas in column C, the PageRank is 2, the multiplier is 0.85, and that's divided by the 3 outbound links, which means that each one lends a score of 0.5, 6, 6, 6, 6, 6, 6, etc. 7. Okay. So now we can use this to fill in our new values for all of the green boxes. So page A gives 1 link to page C, and each link it gives a value of 0.085. So we reference this 0.085 in column A and say, right, that's the amount it's giving to page C. And page C goes to 3 pages, for example, each with a value of 0.5666 recurring, and so it goes into gives that value to pages A, B, and E, and so it goes on. So we're taking these calculations, we're referencing these cells, and portioning out the PageRank values to each of the pages, and then we can add up those columns to find the new page ranks for each page. We have to add back in here the damping factor that we took out at the start, the 0.15, which we add back into every page. So now we have some new numbers for a new estimation of PageRank. Now that's really all there is to the PageRank algorithm. It's just that it gets repeated. I did say that it's iterative, so you'll need to do it again and again and again. So I've got a spreadsheet that I did for all these workings, and if you'd like to have a copy of the spreadsheet, email talk@majestic.com with PageRank in the subject to get the slides and also the Excel spreadsheet I use to do this presentation. But basically, when I get down there, I cut and paste the old value, and I cut it back, paste and into the top to start again, and that redoes the calculation because these cells are referencing the outlink values or multipliers. So I cut and paste it, put the numbers back into the top, and I get numbers, new numbers at the bottom for my second iteration, and again for my third iteration. And I carry on doing this again and again and again. And if you do this over a lot of iterations, I've done it 15 times to show it and plotted the results here, you can see that after an initial jumping around, the numbers start to settle and the PageRank values start to stabilize. And this is what happens in the charts after 15 iterations. If we'd started with all the pages being 1, by the way, which is what most people tell you to do, then this would have taken many more iterations to get a stable set of numbers. So now we've done the maths, we can see which is the most important page on the internet, on our internet. And it turns out to be node C. I don't know if that's the one you guessed, but whether you guessed yes or no to C, it's now time to reveal the wider story. You'll recall I said nodes instead of pages, and that's because this was doing the PageRank at the lowest common denominator that I had at the time, which was 5 nodes. But what if this were actually domains, not pages in this diagram, and that page D, site D had 3 pages within it, and E had 2 pages, and C had 3 pages. I now have an ecosystem with 10 nodes in it, not 5. And more importantly, we now have some internal linking, but we'll break that all down so that we've got 10 nodes so that we don't have internal linking anymore. Now where do you think the power is going to lie? Am I really going to go through all the maths again for these 10 nodes? Well, hell yeah, just for you guys, I am. And here we go. With these 10 nodes, if we go through the algorithm, again, 15 iterations. I haven't done it on the screen, but if you want to see the maths, it's in the spreadsheet. You can see that again, everything goes into a set pattern after a number of iterations. And we can place that on the chart. And here's the actual scores for every single page. And now we see that the winning page, winning node in this example, by a country mile, is E1, the first one in the E node initially. And the C domain seems to be really rather lacking in depth when it comes to it. So when we do the maths at this page level, there's some surprising outcomes and observations that I wanted you to take away. Hopefully now you've seen the maths, and even if you missed some of it, you've got the spreadsheets to help you get there. But because of the differences between the first example and the second example, this is why you should always look at PageRank at the page level, not at the domain level. The winning domain in Site C with Site C in the 5-node model. So if you'd used the domain level modeling, you would have hoped for links from pages which were amongst the worst at the page level. PageRank has only ever actually been done at the page level, as far as we know. Majestic does our own calculations at top level domains, sub-level domains, and page level domains. And in our quest to show higher link counts, we default to the top level domain first, as do our competitors, by the way. But really, it's the page level that counts. And I would urge you, if you're going to really want to try and compare two websites, I would urge you to compare the web pages of the home pages rather than trying to compare the direct sites with each other, because you'll get a better understanding of the comparisons of those pages and those sites. If you build a new site and you only use domain authority in this example, you could easily have got linked from one of the worst possible pages, even though it was from the best domain, because of the internal link structures. And when Googlers say you won't know which ones are going to pass PageRank, how on earth would you know if you didn't have the whole map, if you didn't have the whole calculations on the whole map? You're not going to be able to see the strength of a link if that link depends on the internal links of an entirely different website. That's interesting observation 1. Second observation is that the data doesn't have to be complete, but it works best with a universal data set. Back in 2014, so four or more years ago now, one of our researchers wrote this blog post after somebody in Toulouse, I think it was, did a study using the PageRank algorithm only on Wikipedia pages. And that study showed that Carl Linnaeus, who's a botanist, a famous botanist, was more influential than Jesus or Hitler. Now, Majestic's citation flow as a proxy to PageRank works on a much more universal basis, and we could have told the researcher, or that information would have told the researcher, a slightly different story and a more likely result, as our data uses a larger section of the internet. So every signal in a link is very small and individually is prone to error or opinion, but at scale the error decreases and the confidence level in what we're predicting increases. The next oddity is that the majority of pages have hardly any PageRank at all. This is taking the PageRank that we had in the final node graph by area, a tree graph, and really the top 3 pages in our 10 node model accounts for 75 to 80% of the entire PageRank of the system, which you can see from the chart here. And this last oddity is that your guess of using link counts as an initial estimate is not a good idea, because if we have a look at our original estimates and use the same tree graph, we would have said that page C3 was one of, if not our biggest page by PageRank in our initial estimate because of the number of links coming into it. But if you compare that to the PageRank by area chart, you find that C3 hardly has any PageRank in the final evolution of our algorithms. So I'd like to leave you with these thoughts. I've shown you how this works in a world 10 pages big. 10 pages times 10 calculations, albeit multiplied many times by 0, and then 15 iterations is 1,500 bits of maths. Now Majestic does a similar but different calculation, over 500 billion URLs a day for our fresh index and 1.8 billion pages a month on our historic index. The point is that PageRank proxies are hard to build. They're hard to understand. They're hard to generate. There's a lot of maths and a lot of computing power involved. Finally, PageRank is not about rankings, because pure PageRank doesn't consider context. So be very wary of using page metrics that are based on search visibility for link building. Majestic's citation flow is about the purest correlation to PageRank currently available, although the algorithm is a little different to the PageRank algorithm. Thank you for taking the time. I hope you learned something today.